Next week, we will have an oral recitation about mass spectrometry. And I hope that you will do well, okay? Please study the lesson well.
Did you hear that? Study later? Sure. Where? Guys, do you have any idea about mass spectrometry?
No, I don't know a thing about this.
How about Laura? I can understand the book. It's so complicated. You, Laura?
Well, even I watched it on YouTube, I still couldn't understand things.
Good morning, class.
Morning, ma'am.
It's so hot, please turn on the fan. Faster, faster. Okay, as promised, we will have a oral recitation for today. Cypher,
Yes, ma'am.
what is mass spectrometry?
What do we know? We really don't know this thing, but we searched and found about its history. We've been sitting in discussion for hours. We need a break, teacher, we don't have the brain power. When you ask us our opinion, charged particles are separated. Mom, it's kinda like long division. Everything is difficult. Spectrometry.
Girl, what you're trying to say? Guess I really don't have clue. No, I ain't the J-Time
Spectrometry.
Scale, master charge ratio. His study had begun and was awarded with a prize.
Spectrometry.
Does it have a principle? Yeah, we know you know the answer, so help us understand.
Spectrometry. Oh, and here's a random fact. The instrument was used by a group of scientists. It began with gas discharge, and it has its other name for positive ray analyzer. Oh, it really ain't that hard. You just need to pay attention and know its situation. When you ask me my opinion, it's the instrumental method. Mom, it's kinda like long division. Everything is difficult. Spectrometry.
Girl, what you trying to say? Cause I really don't have clue. No, you ain't on J-Time
Spectrometry.
Scale, master charge ratio. His study had begun with awarded with a prize.
Spectrometry.
Does he have a principle? Yeah, we know you know the answer, so help us understand.
Spectrometry. Oh, and here's a random fact. The instrument was used by a group of scientists. Mass spectrometry is an instrumental technique in which sample is converted to rapidly moving positive ions by electron bombardment, and charged particles are separated according to their masses. There are three principles behind mass spectrum: to measure relative molecular masses, to know the fragmentation of the molecules, comparison of mass spectra with known compounds. Spectrometry.
For a sample of chlorine gas, we can estimate that 75% of the atoms would be chlorine-35 and the remaining 25% would be chlorine-37. These different forms of an element are known as isotopes. All isotopes of an element have the same number of protons, but a slightly different number of neutrons. This concept of isotopes was actually discovered using an analytical technique known as mass spectrometry. For chemical research, the pharmaceutical industry, and in forensic science, there are many techniques and tests to identify a synthesized compound or sample obtained from a crime scene. One crucial technique is calculating the molecular mass of a compound or a sample. This can be done using a mass spectrometer. The beauty of mass spectrometry is that only a very small sample is required. This is important when only a small sample is made or if the evidence is only present in minute amounts. A sample must first be vaporized. Once this is done, The vaporized sample is then bombarded with a beam of electrons. This beam of electrons knocks off electrons from the molecules which make up the sample, creating positively charged ions. This process is known as ionization. The ions formed usually have a +1 or a +2 charge. These ions are then accelerated in an electric field before being deflected by a magnetic field. The pattern of deflection according to charge and mass can then be depicted on a spectrum. The main idea here is that ions with a large mass to charge ratio, meaning a large mass and a small charge, are deflected less than ions with a smaller mass to charge ratio.